This video will talk about finding location of the resultant force. Okay, actually it's not resultant force, but rather than finding location of the vertical and horizontal forces. Okay, so for this question there's two parts. The first part is finding the resultant force and finding the position of the horizontal and vertical force. Okay, so we already found out this one, so we need to find this two. Okay, so therefore let's start. In order, so there's two parts. Okay, you have to find your horizontal position of your horizontal forces, and this case is position of fx. Okay, so it's some forces from, okay, if you remember this force, if you remember this form, sorry, if you remember this formula comes from the, I mean this whole thing comes from the top over force is equals to meter, because you know that force times perpendicular distance is the torque itself. So in this case, graphically in the diagram itself, this is the force multiplied by the perpendicular distance. We call this the position. We call it as x. Okay, okay. So or maybe xe. So it's from the position e to some distance x. So we can say that the position over here is xe. Okay, so this distance is some distance. So this the location of your fx, we call it xe. Okay, so this is what I mean, and therefore if you want to find this, um we actually use the same formula for the, this one, and then you cancel out. Okay, and then for the range itself, I have doubts of it, because if you take 5, if you take an integration from 3.5 to 5, okay, which is saying that you're taking the limits, you're taking the limits from, you're taking the range of this portion over here only, so that you're saying, yeah, so I have a little doubt for that. So it should be, I think it should be from 0 to 5, so it should be from here to here. The resultant will be 3.33 meter, which is somewhere over here. Okay, somewhere over here lah. Okay, so it makes sense lah. Okay, the CG of the rectangular is here, so plus the semicircle, we should be down around here. So yeah, my answer itself is 4.3 meter, so this is near to 3.3, this is near to 4.3 meter. So just to summarize what because I've thought a lot of things that may blur you up. Okay, the purpose of us is to find the location of fx, okay, which is somewhere around this region. The position of fx is somewhat the position of the where you apply the force, okay, on the perpendicular distance from some origin, I mean some pivot. So if you remember that there's a seesaw, okay, there's a pivot and there's a distance, and you have applied a force, this one will actually move, right? So this is what I'm talking about. So you try to find the perpendicular distance, this distance over here, okay, this distance, and therefore this is how we do it. We use the same formula, okay. And then for Fy is a little complicated. Is xb is um the position of the location that we want to find. Xb is the location that we want to find. Okay. So this is location not from xb, rather location xb itself. Okay. So therefore location xb from B, okay, is actually um it is actually the position of the CG. Okay. It's the center of gravity. So in this case, center of gravity for, if you know rectangle is half of the length itself. So this is why we actually use this formula sheet. So it's over. So it's at the board, at the last page of your topic. So you're given circle, rectangle, and triangle. Make sure you memorize it, because there will be 3 types of question. Them, this circular and inclined. So not inclined but rather than, yeah. So make sure you know, because this shape is comprises of rectangular and semicircle or quarter circle. So you have to make sure you know all these shapes for CG. So now, yeah, and then this area of, so the CG multiplied by the area of whatever thing. So this in another case the position of CG. So this is also the position of CG, just that they are about the same. Yeah, I really lost my words. Okay, so I apologize if I talked on lot. So in order to find this one, you have to bring this one down. Okay, and then you just divide. However, you may be tempted that, okay, let's, since this one is equals to this one, you can cancel it. So no, it's not the case, because CG itself, second, when you multiply in the term CG, okay, this is the sum term CG, okay. So the CG itself, there is a CG for, as you know, is for circle and rectangle. So in this case, um, this is the CG for circle. This is the area of circle. This is CG for rectangle. This is the area of the rectangle. So therefore, there is a different values of CG. So this CG is not a constant value. It's just a term to define CG, so that you can understand better. So therefore, when you input your CG and multiply into your area, you eventually get whatever distance that you want. Okay, because the CG itself may change across some area. Okay, so this area is this. So imagine this is the area of the rectangle. So your CG may be somewhere, for rectangle is here, but however, what if your shape is like this, right? So you have to really find, you have to settle up different shapes, right? So you find the CG over here, 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 and then you sum them up to get the average CG. So this is what we are doing. Okay, so in a very easier way, we're talking about a quarter circle and the rectangular circle. So we find our CG of this area, and then we find the CG of this rectangle, the area of the rectangle. So I hope you get what I mean. So you just sub in your values and you will get your position from B. Okay, the position from B. So hope I didn't confuse you anything. Okay, mainly that the position of XB and the position of the water, the position of FX. So yeah, so just to summarize, to find position of Fx, you can use the same old formula, the torque over force equals to meter thing, which is also, in other words, this is the formula that you can actually use. So but it's in terms of the forces of x. Okay, so as you know, so just to let you know, this this term is the same as the as you go and find your fx. Okay, when you're finding your fx, you're using this term. Okay, so when you're finding your fy, I mean your position of fx, you're gonna find using the same term over here, the forces. And then for finding the position of fy, you have to know the relationship. So this whole thing is equals to this thing. Okay, in other words, this is equals to this. But however, CG for different shape is different, so therefore you have to multiply in the different CG of different shapes in order to find XB, the position of our overall CG in the Y direction. Okay, so the resultant, I believe, is the position of Fx and the position of Fy. You do the trigonometry method. Okay, which is similar to that. Okay, and then you'll find some values. Okay, so this is the first part. We actually find our resultant force, and this is the second part where we attempt to find the horizontal forces and the vertical forces. and hopefully I didn't make anything cock up lah. Cause yeah, I'm a little shag boss. And then one one discrepancy is over here. I have no idea how I will solve this, but yeah. So I shall see you in the next video for summary. Okay, so I already cleared all this stuff. Okay, and brief talk about the gravity. I already talked about the center of gravity, which is this page. Okay, so in the next video I'll just do a summary for this whole topic, what I've learned so far, and then we record it another day. So see you.